This lecture is on selective precipitation. How can one determine if a precipitate is formed? The formation of a precipitate is dependent on the initial concentrations of the principal ions. Let's look at an example. If Q is greater than KSP, a precipitate forms. If Q equals KSP, an equilibrium process, and no precipitate forms. If Q is less than KSP, no precipitate forms. Predict whether a precipitate will form when each of the compositions are added together. Assume volumes are additive. See your textbook for KSP values. 650 milliliters of 0.0080 molar K2SO4 and 325 milliliters of 0.50 molar PbCl2. The solution begins by writing the equilibrium equation where solid PbSO4 at equilibrium forms lead-2 and sulfate ions. The initial concentration of lead-2 ion is 0.17 molar, and the initial concentration of sulfate ion is 0.0053 molar. Solving for the reaction quotient value, it equals 9 times 10 to the minus 4, and since the KSP value is 6.3 times 10 to the minus 7, Q is greater than KSP, and a precipitate forms. Question 1 is predict whether a precipitate will form when each of the compositions are added together. Assume volumes are additive. See your textbook for KSP values. 175 milliliters of 0.15 molar AgNO3 and 700 milliliters of 0.0080 molar NaCl. Selective precipitation, also known as fractional precipitation, this involves isolating the formation of at least one solid from being formed based on initial concentrations of a common ion. Let's look at an example. Silver nitrate is added slowly to a solution containing 0.020 molar Cl minus ions and 0.050 molar Br minus ions. What is the concentration range for where formation of AgBr can be formed without precipitation of AgCl? From Burge reference, where the KSP of AgBr and AgCl values are 7.7 times 10 to the minus 13 and 1.6 times 10 to the minus 10 respectively. The result is silver ions concentration from AgBr is 1.5 times 10 to the minus 11, and silver ions concentration from AgCl is 8 times 10 to the minus 9 molar. This is the silver's concentration range in order for only AgBr to be formed without interference from possibly forming AgCl. Question 2 is to calculate the concentration of Ag plus in moles per liter necessary to initiate the precipitation of A, AgCl, and B, Ag3PO4 from a solution in which Cl minus and PO4 minus are each 0.10 molar. KSP for Ag3PO4 is 1.8 times 10 minus 18, and KSP for AgCl is 1.6 times 10 to the minus 10. For the remaining part of this lecture are solutions to review exercises or problems. Please view only after completing these exercises.